When I do this lecture, I'm going to make an assumption that you actually don't know anything about circles, at least in some respects, because we're going to go over all the definitions and such. And so just making sure circles are going to appear as brand new to you, or as we kind of learned with other polygons. And the other thing, this really should say 832, not 822. So probably something to know or have in your back pocket. These definitions aren't written on your paper, so please feel free to write them down as I say them, and feel free to pause, or etc. as I say them. Okay, so a circle, by definition, this is, at least my definition I have, is an enclosed shape. So in other words, this is not an enclosed shape. This is an enclosed shape. An enclosed shape where the set of all its points are equidistant from the center. I should say its center. And I'll explain what that means in 1 second. A circle has 0 sides and 0 angles. So you know a circle as this thing. Okay. Now, check this out, because this is perfect. This is my tool that I use on my smartboard system. When I use this tool, I stretch and I shrink. And you can notice there's a dot in the middle. And these points, they don't look like points to you. It looks like a giant rim or like a curvy side going all the way around. But this set of points are always the same distance from the center no matter where I go. So when I grow out, everything goes out the same distance. And that's really what it means. And when that point disappears, let me put in a new point again. When you see a circle, sometimes on problems, they'll have a letter assigned to it. Maybe they'll call it C for circle or for center, or circle O, or whatever it is. So you might see something like this. Like when we say triangle ABC, sometimes they'll say this, and this means like circle C. And that describes the circle with the center point being called C, or whatever else. So here's a picture example of a circle. And like I said, it doesn't have any angles. It's always assumed to be rounded and curved off. An angle is an actual 2 straight lines meeting at one another, or whatever else. Okay. And again, this isn't called a side. This is just the rim. So this part is called the circle. See, the black part I'm going around. This inside part is not the circle, but this is the center where these points go around. That's my definition, assuming that you don't know what a circle is. Okay, and I don't really have a mathematical example for it, but we'll go into those for other ones. Okay, the radius of a circle is the distance of all the points, of all the given points from the circle, from the center of a circle. So let me duplicate, or let me group this together, and then I'll clone this as I go along. So here's a circle again. The radius is this guy. If I go from the center of a circle to the actual circle itself, this distance from center to any point on the circle is called the radius. And let's denote that with a value, or with a letter. Let's call it R. Okay, this is a radius. This is a radius, this is a radius, etc. All these are radii. The plural for radius is radii. Okay, let's give an example here. What is the radius of this circle here? If I go draw you something there, here, here, and I give you values of 3, 6, and 4. My radius is 3. It's the one drawn from center out to circle right here. This is a chord. It's called a chord. And this, although I didn't draw perfectly, I would call this the diameter, which is going to be your next definition. Okay, so radius, that's an R. Let me try that again. Radius equals 3. Okay. The diameter is the longest segment that can be made inside a circle. So I want you to think about it for a sec before I do the other points there. I'm going to draw different chords, and chords are any segments inside a circle that touch from circle to circle. Let me try that again. Blue. Okay. I'll draw that. Okay, can I get longer? Yes, this is longer. Can I get longer? Yes, this is longer. Can I get longer? Yes, this is longer. Can I get even longer? Yes. If I go right in between the center, I can get as long as I possibly can inside a circle. So just go ahead and look at that again. If I go from one point to another, the longest I can get, not here, not here, I'm going longer, 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 oh, longer, and boom. That's the longest I can make any segment inside a circle, and that's called the diameter. So this, you'll denote it with the letter D most often. It passes through the center point, and the length of the diameter, check this out. One of these is a radius. Another one of these is a radius. So two radii of a circle are the same length as the diameter of a circle. So you see this radius here? Whatever this radius is, the diameter of that same circle is 2 times r. Okay? So what if I asked, what is the diameter of a circle with radius 6 inches? Okay? So if I have a circle with radius 6 inches, that is to say, this is 6. What's my diameter? It is 2 times your radius. So it's 2 times 6, which is 12 inches. Okay? These are both 6. Should be clear enough. I'm just making sure you know, because once we get into circumference and such, you can use twice the radius or the diameter, either way you want to put it. Okay, pi. Pi is this, it's a Greek letter, and we can think of circles like pies as well, or pizza, as I'm going to use in some examples. So pi is a fitting term to use as well, and this is the symbol that they use. You're going to practice drawing them or writing them, whatever. You don't have to get too fancy. Pi. Now pi is a constant, and what that means is it's just a number, just like 9 is a number. Okay? It's just a number, but it's such a long number, we don't want to say the number over and over and over again. In fact, since it's an irrational number, it never stops. It never repeats anything. It's a non-consistent pattern of values. It's 3. Let's see. I know it's like 3.14159265359. It keeps going. It goes on forever. You can Google search what it does. If you memorize like 50 digits, that's awesome. But it has an infinite number of values here. But 3.14 is the one that we often round it off to. There's a pi button on your calculator, even on your phone, that you can use, and I'd prefer that you use that whenever you reference pi. And in fact, I prefer to leave answers in terms of pi. So we're going to do some examples down here, but it's a common ratio. So basically what it is, I mean, I'm going to do it with circumference in a second, but it's the common ratio of a circle's circumference to its diameter. So, you know, ratios, right? Ratios are like 4 to 3, whatever. There's a value, in fact, a fraction that's pretty close to it because it approximates the first 3 is 22 to 7. So let's say I had a circumference, which again, we're going to talk about. I have a circumference of a pizza. The circumference, the thing around it, and the pizza is 22 inches, and its diameter is 7 inches. That's just how it is, or about 7 inches. And this ratio is 3.14. That's what every circle ends up being. It just has that ratio. So we use that to help us out. Okay, circumference. It is the quote-unquote perimeter of the circle. I only say quote-unquote perimeter because perimeter is the addition of all of your sides. And in a circle, there aren't technically any sides that we're going to be adding up. So we just use this, and there's a formula to denote this. So our circumference C is equivalent to our diameter times pi. So just like I said, it's that common ratio. If I take the diameter of any circle and multiply it by pi, I have the same thing as its circumference. So if I take this circle here, and I shouldn't call this C anymore because now we're talking about, well, it doesn't matter. Let's call it O. This is now circle O. The circumference is the rim around this. If I took a measuring tape around a pizza and went perfectly around, and then looked at how long it was, that would be whatever the circumference is. Now the circumference, like I said, shares a ratio with the diameter. And that would be, if I took this diameter and I multiplied it by pi, pi is just this constant that allows you to say, I take this multiplied by 3.14, that's the equivalent to the length. Let's do an example. Let's say a circle has radius. I can't spell circle. Circle's radius is 2 inches. What is circumference? I'll just put C. So what's the circumference of a circle with a radius of 2? Okay, so here's what we're going to do. I'll put another circle here for now. You can draw it however you need to. Its radius is 2, so this guy right here is 2. The diameter is twice the radius, so I put in 2 formulas here. You can either say the circumference is diameter times pi, or 2 times r times pi, because the diameter is twice the radius. So you can use one or the other, it doesn't matter. So the diameter is twice this, if you want to look at it that way, though. It's 2 2's, which is 4. So this whole diameter is 4 inches. If I multiply 4 by pi, I get my circumference. So circumference is 2 times 2 times pi. Circumference is 4 pi inches. You'll notice I left my answer in terms of pi, which means I didn't round off. You could round it off, and I could use the calculator and say it's about 12.5 something or 12.6 something, whatever it is. But this is a perfect answer in that it's not rounded off and it's whatever else. Maybe you won't like the look of the number that way because you can't really compare it and make sure you're right. But that's as right as you can actually get. Okay, the area. The area of a circle is the fill-in stuff. So while the circumference was taking the outside of it, or taking the actual circle itself, because remember the circle is actually just this rim, the area is filling in the inside. And I do have a paint tool. Let's fill her in. Yeah, I don't know if I'm actually filling it in or not. I guess I'm not. Anyway, if I took the paint bucket there and was able to fill that in, trust me, I would. So that is this stuff inside here. Just like any other area, but this area isn't as easy to obtain. There's no base and height. So there's this thing that this guy figured out and said, if I take, and that's what this is going to say right here. If I take the radius of a circle and the circumference of that circle, like so. Again, I'll call this circle O. So if I take the radius and circumference of the circle, the area is the equivalent to finding the area of a triangle whose base is the same length as the circumference. So if I take this and kind of roll it out, if you know what I mean, if I take my measuring tape and measure it off and then I lay it out straight, this would be my C. And then my R would be the height of this triangle, like this R right here. This has the same area, boom, as this. Okay. So basically the way the formula pans out is in a triangle, it's 1/2 base times height. Okay. If your base is your circumference is the same as finding is right here. So I should probably put A is 1/2 C times R. A circumference is the same as twice the radius times pi. and r is r. So now let's start canceling things out. 1/2 times 2 is 1. They cancel out. R times r is r squared. So the area of a circle is pi r squared. Now again, it's probably something that you know already. But just in case you didn't, there's your area right there. Let's call it A. That is pi r squared. So take the radius and square it and multiply it by pi. Okay. So I'm going to do an example with you, and maybe they make you work a little bit for it. So maybe, and I hope you don't mind I move some stuff or maybe even delete it, but I'll go and move this. Let's say I want to find the area of a circle that has a circumference of, I want to do a good number, 10 pi centimeters. So area of circle with circumference 10 pi centimeters. So basically what it's saying is if I have a circumference of 10 pi, this thing is 10 pi, what's the area? What's the fill-in? So the important thing here is the area is pi r squared. Circumference we know is 2 pi r. We could say diameter times pi, or 2r pi or whatever else. But the important thing is I need to get radius here. Okay, I need it because I need to use radius here to get area. So I know my circumference is 10 pi. So 10 pi equals 2 pi r. If I divide both sides by 2 pi, I'll solve for r. So 2 pi here cancels out. And r, 10 over 2 is 5. Pi over pi, pi's cancel out. So you're left with 5. So your radius is 5 centimeters. Okay? If I have a radius of 5 centimeters, the area, which is pi r squared, is pi times 5 squared. 5 squared is 25, so your area, is 25 pi square centimeters. All right? So here was my circle. It had a circumference of 10 pi, so I take the measuring tape, fill it, or whatever, I look back, it's 10 pi, which is it's a little over 30. It's about 31, or 35, yeah. The area is 25 pi square centimeters, so that's probably about 80 square centimeters in general. Again, you can multiply by pi if you need to. I like to leave them in terms of pi. I'd prefer you did because a lot of things in the book will use that. Especially when, if they give you circumference, they won't give you a rounded number like 31.4 and then say find the area, because now you have to divide by pi, and now you're going to use 3.14, and it's just going to be weird. They're going to use pi in there. Okay, those are the things you probably knew about circles, though, anyway. So now we're going to start talking about other portions of circles. And we've talked about central angles already. I'll apply it to circles. So remember, in polygons, the central angles were the vertexes that were formed inside the center. When we drew the radii of any polygon, like say I had an octagon right here. Excuse me. The center's right here. There are 8 radii in an octagon. Okay. Excuse me. In an octagon, there are 8 central angles, and all of them are congruent. Okay. So, in a circle, though, there are an infinite number of radii. I can have a radius here. I can have a radius here. I can have a radius here. I can have it here. I can have it in there. I can have it in there. There's an infinite number of radii. So central angles are formed by any of the radii that I draw. Let's get that out of the way. Let's draw some, though. Let's draw a few radii and then get the central angles out of it. Now, just like anything else, central angles add up. Whoops. Central angles add up to 360 degrees. So let's say these are a couple central angles here. Okay. There's one right here. There's one right here. Now you can tell they're not congruent. So I'll draw them with different hash marks. Okay, 4 different central angles in this. They're not congruent, but they add up to 360 degrees regardless. Okay. Mathematical example. Let's say that I have a circle here, and let's draw 2 diameters that go through it. Now, if I draw two diameters, you're going to notice something here, and it is that I'm going to create vertical angles when I do. I draw a diameter here, and I draw a diameter here. I've created sets of vertical angles. They're also central angles. So here I have 4 central angles. Here's one, here's another, here's another, here's another. Okay, let's say that this is 20 degrees. And then I say, what is the sum of the measure? Let's do these ones. Let's say, what is the sum of the measure of these two central angles? Of the red ones, formed by these green things. So what's the sum of this measure? So as you work through that, you start to say, okay, well, this is 20 degrees. This is a vertical angle, so this must also be 20 degrees. So these two add up to 40 degrees. 20 plus 20. If these add up to 40 degrees, and all of them add up to 360 degrees, then this total is whatever is left of 360. So I do 360 minus 40, and that's 320. So your central angles add up to 320 degrees. These central angles add up to 320 degrees. Okay? So that's an example of central angles. Okay, a sector. A sector is not an octagon. Let me get rid of that. A sector, again, I said I'd be referencing pizza. Here we go. Let's do it. Let's say this is a pizza. Nice looking pizza, too. Let me see if I can ungroup this. Let me get rid of this C. Okay. Let's make a pizza. Start to make a pizza. You start to look at things right here. In fact, you don't even need to, but I just want to give you an example first, and actually I want to redraw this after. And no, it's not a basketball. A pizza slice would be a sector of this circle. Boom. Or of the area of the circle. I'm sorry. So if I look at the entire area, sector is a portion that's made from a central angle out to the circle, like this. So it's formed by its radii. And you can then determine that the area is by comparing the entire circle to the area, to the proportion made of the central angle to the rest of it. And I know that that wording sounds weird, so I'm going to do an example, and it's going to make sense as far as the proportion goes. It's going to start making sense here. So let's say that, let's kind of use this example over here again with the circles. Let's say I wanted to find out. Okay, come on. Let's say I wanted to find out what the area of this sector is right here. Okay, this will be my objective. I want to find out what this area is. And let's say that the let's say that the diameter of this circle is 8 feet. Okay, so I have a diameter of 8 feet. That's the entire green line right here. This whole thing is 8. I want to find the area of this sector right here. So what I'm going to do is set up a proportion. And here's how it's going to work. First, let me move this over. Again, let me try and move this over. And I'm actually going to write this in the... Come on, are you serious? Let's go. There we go. Thank you for moving. Half of this lecture is me trying to move something. If I take the measure of a central angle, like this central angle, divide it by 360 degrees, the sum of all my central angles. So let's say this was 90, which is not, okay, so let's say it's 45. This is 45 degrees compared to 360 degrees. That's 1/8 of my circle. I'm sorry. That central angle makes up 1/8 of all the central angles in here. So that's 1/8, right? So just as an example, whatever that central angle makes up, because it forms this sector, the sector will also be 1/8 the area of my entire circle. So I want to set up a proportion where I find my central angle divided by 360, and then I compare that to my area of sector, divide that by the area of my circle. And my circle's area is found by pi r squared. Okay, so this is a proportion that we're going to set up. Maybe right now it doesn't make sense because you wrote this down and you said, I don't really get what we're doing yet. But let's do this example now that we have this proportion set up. So basically the one we have to find is this. We don't know this. The rest we can determine based on the information we have. So I want to find the area of this sector. The two things I need to figure out now are the area of the circle and what my central angle is. What this central angle is. So what is that central angle? Well, this is 20 and 20, so those are 40. These two add up to 320. If both of them add up to 320 and they're both vertical angles and they're congruent, 320 over 2 is 160. So each of these are 160 degrees. So this one right here is 160 degrees. Okay? So if I compare 160 degrees to 360 degrees, which is 16 over 36, 8 over, I'm sorry, yeah, 16 over 36, 8 over 18, 4 over 9. So this is 4 over 9. I'm just going to simplify it now. 4 over 9. So this central angle makes up 4/9 of all of my central angles. So the area of this sector makes up 4/9 of the area of my entire circle. Let's call that unknown area for now x. The area of my entire circle is pi r squared. R is half my diameter. So if my diameter is 8, my radius is 4 feet. So my area of the entire circle is pi times 4 squared, which is 16 pi. So my area is 16 pi. So here's the proportion I'm setting up. And let's look at that one more time before I kind of cut out from that and continue on the problem. And it looks like I'm not going to get a clean number here, really. My central angle right here makes up 4/9 of the central angle of the entire circle. So the area of my sector will also be 4/9 the area of the entire circle. So 4 is to 9 as x is to 16. Whatever x will be, it will be 4/9 of 16. Okay, now whenever you set up proportions, I think you guys like to cross multiply. I'm sorry, 16 pi, I should say 16 pi. But you guys like to cross multiply, so let's go and do that. 64 pi, that's 16 pi times 4 equals 9x. And x equals 64 pi over 9 square feet. Okay? Is that number pretty? Not really. Is that an answer? Absolutely. I can't simplify this value for you. I could round it. I'd prefer not to. But you could. It would probably be somewhere in the 20s, like 25 or something like that. But that doesn't matter. This is still an answer. Maybe if you do want to compare it to the 16 pi, at least to know it's less than it, which you should want to know that. 64 divided by 9, 63 divided by 9 is 7, so it's about 7 pi. A little more than 7 pi. 7 pi is less than 16 pi. And it's less than half of it, which makes sense. Okay, so you might want to pause that to write that stuff down because I'm about to remove it. At least this portion right here. Okay, and the last part that we're going to look at are arcs. An arc, if the pizza slices make up sectors in the area, an arc, let's do a center. An arc is like the pizza's crust. So let me just draw 2 radii for you. Okay. Like, here's a slice of a pizza. I just want to take off the crust. And by crust, I mean the portion of the circle. So this isn't thick crust, Don't assume it to be thick crust. Just assume it to be this length right here. If you take the measuring tape and just measure this portion, how long is it? Okay, so an arc can be measured in two different ways. If I have this called AB right here, this will be called arc AB, which looks like that. This arc is just like a segment, only it's curved. The arc measure is the same as the measure of the central angle. So if this angle was 50 degrees, the measure of arc AB is also 50 degrees. Okay, that's one way to put it. The other way is you can find the length of the arc, and that's the one that I'm more concerned about. But I just want you to keep in mind when we talk about, if they talk about arc measure of 50 degrees, that's 50 degrees out of 360 degrees. So it's, you know, again, it's a proportion. It's some amount. Here, let's call it 60 to make it fairer. This is 60 degrees out of 360 degrees. So this arc measure is 1/6 of the entire circumference. So the question is, what can its length be? Okay, its length is a portion of the circle's circumference. So just like when we did area before, let's do circumference. Let's do an example with pizza. Let's say that I ripped off a slice of pizza. Now let's rip off 2 slices of pizza. I have a pizza here. It'll be an 8-sliced pizza, and we have to give it. I'm not sure if you've ever. I know you've had pizza. I'm not sure if you've ever been told how pizza works. If they give you a, let's call it this time, let's call it a 14-inch pizza. If they give you a 14-inch pizza, that means it's the diameter of your pizza is 14 inches. So if you ever ask them, oh, how large is your medium? They'll say, oh, it's 8 inches. That's the diameter they're talking about. So you can figure out what your area is. And in fact, that's how I figured out what's the most viable option to use based on the price. We'll actually probably do a problem with that. So I have another pizza, not a basketball, and I want to rip off 2 slices of it. Okay. I rip off 2 slices. I want to know how long the measure of the crust is of 1, 2 slices. Okay. This pizza's, this is a, we said 14-inch pizza. So I want to know how long this portion is of my crust. And I'm sorry if you need more room in your boxes. You should probably draw these smaller because you know you're going to do math examples here. Okay, to do this, what I'm going to do, just like we did above here, I need to set up a proportion. I need to figure out the measure of my arc, the measure of my central angle. I need to figure out how many degrees this is out of my entire pizza. Remember, the entire pizza is 360. What's the measure of this right here in an 8-sliced pizza? And assume all slices are congruent. They have congruent angles. So in these central angles here, if I divided this evenly, I have 360 over 8, which is 45. So each one central angle is 45. 2 central angles is 45 times 2, so that's 90. 45 times 2 is 90 degrees. So one central angle here, or I'm sorry, so 2 slices here is 90 degrees. Okay, so now I'm going to set up a proportion here, and I'm going to do it over here. And again, sorry if you're running out of room when you do this. 90 over 360, 90 degrees out of all of my 360 degrees, is equivalent to, I need to find my portion of my crust, right? I need to find how long this crust is. Let's call it an x. Whatever 90 over 360 is, it's the same as x over my circumference of my circle, right? A portion of my pizza over the entire pizza is the same as a portion of my pizza over my entire pizza, assuming we're talking about the same portion. So portion over entire equals portion over entire. The circumference of my pizza is diameter times pi. My diameter is 14, so my circumference is 14 pi. So I'm taking this over 14 pi. Okay, 90 over 360. You go in your calculator, you figure out it's 0.25, which is 1 over 4. So 1 over 4 equals x over 14 pi. Cross multiply, we get 4x equals 14 pi, and x equals 14 pi over 4. This one can be better simplified. This can be 7 over 2, or this can be an exact decimal, 3.5 pi inches. Okay. And again, I'm sure when you took out the measuring tape, you'd get somewhere closer to 10 or 11 inches. Okay. So in a 14-inch pizza, 14-inch diameter, this is about 11 inches. 3.5 times 3.14 or whatever. Kind of cool to know. Okay, very last thing I want to do here is we went over this homework problem in class. We're going to do it kind of a, not really a different way, but kind of a way that we looked at it with circles. We're going to find the area and perimeter of the shaded region. So area of the shaded region is obvious. Perimeter, I mean, how long are these parts? And you can tell it's 10 plus 10 plus 10, which is 30. But go with me here. Let's do perimeter first. It'll be kind of easier. If I look at the central angles formed by the radii, these guys right here, I want to figure out how large the central angle is. These three central angles together. So one central angle is 360 over 5, which is 72. Three central angles is 72 times 3, which is 216 degrees. Okay, so this is 216 degrees out of a total of 360. So 216 over 360 is equivalent to the perimeter we want to find out over the perimeter of the entire thing. So see if that makes sense as we talk about that. My central angle out of all 360 degrees is the same as finding out what this portion of my perimeter is out of the entire perimeter. And the entire perimeter is 10 times 5, which is 50. Now 216 over 360 actually simplifies to 3 over 5. My suggestion is when you do cross multiplication, first figure out if you can simplify anything. Otherwise, you're going to get some massive numbers. I don't want to do 50 times 3, 216. So 50 times 3 is 150. So 150 equals 5x, and x equals 30 units. Okay. So that's another way of figuring it out. Again, for this, maybe not so conducive, but just to see that you know, when we set up proportions, it's the same thing. Maybe you can make more sense out of it now that you see it this way. And finally, area. Let's find out how much coverage all this is, the shaded region. Again, central angle. We do 216 over 360, which is 3 over 5. I'll stick with that. Equals x. So this area we want to find out, the same, that's the 3/5 of it. 3/5 of the entire area, of the entire thing. I don't really remember what it was. So my apothem, this is 5, and and we used trig. I think we got like, oh, I don't even remember anymore. I remember that the area of this thing was like 102. So if 102 is 3/5 of it, and it's 34, we got like 136. Let's say it's 170. Okay, that's maybe not perfect, but let's say it's 170. Let's say that's what we get. Okay, and then you cross multiply. So 3/5 of my central angles, so this should be 3/5 of it. So cross multiply, 510 equals 5x, and x equals 102 square units. Okay, so it's the same kind of thing. We're just looking at it a different way. We set up a proportion by using our central angle to the rest of it. We've always done that, but maybe you didn't write it out. You thought it in your head. Okay, so I'm just making sure you can see those in a different light, because this is how they have to be used in circles. This is the only way you can look at them. Okay, so those are circles in a nutshell, and yeah, so make sure that you see things that way. Okay.